All right, let's jump right in. We're going on a trip billions of light years back in time to tackle one of the biggest, brightest mysteries in all of astronomy, the quasar. So, what exactly are these cosmic blowtorches that can outshine entire galaxies? Well, that's what we're here to figure out.
Okay, so let's set the stage. I want you to picture it. It's the early 1960s. Radio astronomy is this brand new, exciting field, and scientists are pointing these massive dishes at the sky for the first time. And they're picking up all sorts of stuff, right? But a few of these signals are just weird. They look like tiny points of light, just like stars. But they are blasting out radio waves with an intensity that just made absolutely no sense. Seriously, it defied all explanation. A huge cosmic puzzle had just landed in their laps.
So at first, they gave them a pretty straightforward name, radio stars. Makes sense, right? They looked like stars and they were putting out powerful radio signals. Seems simple enough. But the more they looked, the more they realized something was very, very wrong. These things just weren't behaving like any star they'd ever seen.
So they came up with a more official-sounding name, quasi-stellar object, which, if you break it down, literally just means star-like object. It's basically the scientific way of shrugging your shoulders and saying, well, it kind of looks like a star, but we got nothing. That mouthful was thankfully shortened to what we know today, quasar.
And you can really see how this mystery deepened over time. It all kicks off in the 50s with these weird, unidentified radio signals from space. Then, bam, 1960, they managed to pinpoint one. It's called 3C48, and it just looks like a faint little star. A year later, the term radio star starts getting thrown around. But by 1962, things are getting even more confusing. When they looked at the light signature from these things, what we call a spectrum, it was just a total mess. It didn't match anything they had ever seen.
And this quote right here, it perfectly captures just how stuck everyone was. See, there was one idea floating around. Maybe it was a massive redshift. Now that would mean the object was unbelievably far away and flying away from us at a ridiculous speed. But the numbers just didn't add up. I mean, for something to be that far away and for us to still be able to see it, it would have to be putting out a truly insane amount of energy. It just seemed impossible. The idea was so out there that leading astronomers like Jesse Greenstein were basically saying, nope, no way, that can't be it, back to the drawing board.
So the answer wasn't going to come from 3C48. Nope, the key to finally cracking this whole thing came from another object, one that was even brighter and had been kind of hiding in plain sight the whole time.
So in 1963, this astronomer at Caltech, Martin Schmidt, decides to take a closer look at a different object, 3C273. Now, this thing was one of the brightest radio sources up there. And, using a really clever trick, they actually used the moon to block it out for a moment. They were able to nail down its exact position. Schmidt was finally ready to get to the bottom of its bizarre light spectrum. And this is it. This is the big aha moment. Schmidt is just staring at these weird spectral lines, and suddenly it clicks. The pattern wasn't weird because it was some strange new element nobody had ever seen. No, it was the totally normal, everyday pattern of hydrogen, but it was stretched. It was redshifted by a huge amount. The only way that could happen is if the light waves themselves were being stretched out because this object was flying away from us at an absolutely mind-boggling speed.
I mean, just stop and think about what this implied. It was staggering. First off, a speed of more than 16% of the speed of light. Then, a distance of billions of light years away. And here's the kicker. If it's that far away, but we can still see it, that means it must be as bright as an entire galaxy. An entire galaxy's worth of light, all coming from a single tiny point. This was a complete game changer. These things weren't just weird stars in our own galaxy. They were cosmic lighthouses shining at us from the very edge of the observable universe.
Okay, so problem solved, right? Well, not exactly. This huge discovery just opened up an even bigger mystery. What in the universe could possibly be powerful enough to generate that much energy? The answer, it turns out, is found at the very center of galaxies, and it involves the most extreme objects we've ever imagined.
So today, we know that a quasar is a type of what's called an active galactic nucleus, or AGN for short. And what's the engine driving this whole thing? A supermassive black hole. We're talking millions, sometimes billions of times the mass of our sun, just sitting right there in the heart of a galaxy. So here's the cool part. Here's how it works. And it's really important to get this. The black hole itself isn't what's shining. Black holes don't give off light. Instead, think about all the gas and dust and stars in the area.
As they get pulled in by the black hole's gravity, they don't just fall straight in. They start to swirl around it, faster and faster, forming this huge, flat, spinning whirlpool of superheated stuff. We call that an accretion disk. And the friction in that disk gets so intense that it heats up to millions of degrees and glows brighter than anything you can imagine. That glowing disk is the quasar.
And the amount of energy this process creates is just bonkers. It's ridiculously efficient. Get this. To shine as brightly as our entire Milky Way galaxy, a supermassive black hole only needs to snack on about 5% of our sun's mass in a whole year. And the really bright quasars, they can outshine our galaxy thousands of times over. They are, without a doubt, the ultimate power plants in the universe.
And if you're wondering how much fuel these things have, well, just to give you an idea of the scale we're talking about, astronomers looked at one quasar and found a cloud of water vapor around it. How much water? Oh, just 140 trillion times all the water in all the oceans on Earth. That's the kind of gas tank we're talking about here. It's just mind-bending.
Okay, so we've got this incredible engine, right? A supermassive black hole, a glowing hot disk, and sometimes it's even shooting out these enormous jets of material from its poles. But here's where it gets even cooler. For a long time, astronomers had found other weird, super powerful things out there, like blazars and radio galaxies. And the amazing part? It turns out they're all the same object.
It's all about perspective. It's all about what angle you're looking from. So let's say you're looking at this thing from the side, okay? From that angle, there's usually a big, thick donut of dust blocking your view of the bright center. So you can't see the glowing disk. What you can see are the huge jets of material shooting out the top and bottom. And those jets create these massive clouds that glow in radio waves. When you see that, you call it a radio galaxy.
Okay, now, let's just change our angle a little bit. We're going to tilt our viewpoint so we can peek over the top of that dusty donut. And what do you see now? You get a direct view of that unbelievably bright accretion disk. And that, my friends, is what we call a quasar. You're seeing the dazzling central engine head-on.
And for the grand finale, what if you happen to be looking straight down the barrel of one of those jets? A jet that's blasting material right at you at nearly the speed of light. Well, then you see a blazar. It's the most intense, most energetic version of all. So you see, it's the same engine. Radio galaxy, quasar, blazar. Just 3 different points of view. For decades, scientists thought these were totally separate things, but it was just one cosmic beast seen from different angles. How cool is that?
So quasars are obviously incredible, but they're not just some cosmic light show. Because they are so unbelievably far away, they actually give us a very special kind of gift.
You have to remember, light takes time to get from one place to another. It's not instant. So when you look at a quasar that's, say, 10 billion light years away, you are seeing light that left that quasar 10 billion years ago. You are literally looking back in time. Quasars are our time machines. They let us see what the universe looked like when it was young and chaotic and full of fuel.
And that's why they're so important. Quasars really tie together so many big ideas in astronomy. They are the smoking gun for supermassive black holes. They're our window into the early universe. They even show us how big events like 2 galaxies smashing into each other can basically flip a switch and turn a quasar on. And you know, that brings this whole story right back to our own cosmic backyard, because our Milky Way has a sleeping giant at its core, a supermassive black hole that's pretty quiet, at least for now.
Which leaves us with this one last incredible thought to chew on. Since we only see quasars very far away, and therefore very far back in time, maybe they aren't some weird, rare thing. Maybe a quasar is just a phase, a violent, brilliant, youthful chapter in the life of every single galaxy, including our own. It probably means our Milky Way was a raging quasar billions of years ago. And, you know, in about 4.5 billion years, when we're set to collide with the Andromeda galaxy, all that new gas and dust could be just the fuel needed to wake up our sleeping giant and turn the center of our galaxy back into a quasar. For some other astronomers, in some other distant galaxy, to look at and wonder, what is that?